before y'all get started, did you get to choose your own teams? How did y'all get to be grouped together?
Drafted.
Drafted?
Beta C drafted us.
Yeah.
We put all our names in a little box and just kind of.
So it was just random drawing from a
Yeah.
hat? Okay.
What about grade levels?
Oh yeah.
Yeah,
Two sixth
Two
graders,
graders,
two
two
seventh graders, two
two
eighth
eighth
graders.
graders.
Okay, all right, thank you.
Hello, my name is Sam.
I'm Maria.
I'm Evelyn.
I'm Liza.
I'm Taylor.
And I'm Heston. We are smelt astronomers.
We are proud to present our presentation on CubeSats.
In the making of our CubeSats, we followed the engineering design process, which consists of 9 steps that includes
Define the problem,
brainstorm,
Research.
develop ideas,
Choose best idea.
model and prototype,
test and evaluate,
improve design.
And communicate results.
The first step is to find the problem. Our problem is to design and construct a CubeSat.
For the brainstorming process, we went online and looked up pictures of CubeSats to give us an idea of what they look like. Here are some pictures that we found online.
But what else is there on CubeSats?
well, according to the National Aeronautics and Space Administration, or NASA website, the CubeSat Launch Initiative, CSLI, allows the launch of CubeSat projects designed and constructed and functioned by students, teachers, and staff to get hands-on flight hardware growth experience.
CubeSats are also approximately 10 by 10 by 10 centimeters long, with a volume of about 1 quart and weigh about 3 pounds.
Once a CubeSat is launched into space, it is deployed by a mechanism called the Polypico Satellite Orbiter Deployer, or PPOD. The PPOD was manufactured and designed by the California Polytechnic State University of San Luis Obispo, California, to integrate CubeSats into launch vehicles.
One fun fact about CubeSats is that it is inspired by 4-inch cubic plastic box used to display Beanie Babies in stores. Bob Twiggs, professor of Moorhead State University, first established the larger 10-centimeter cube as a guide for the new CubeSat idea.
For developing ideas, we paired into groups of 2 and designed 3 CubeSats each on a program called Autodesk Inventor. These are the 3 best CubeSats each group designed.
As we chose our best idea, we came together to decide what stood out on each cube and put them together to create our final design.
Afterward, we added and manufactured or 3D printed our CubeSat.
Using foam board as a representative, we added solar panels to our cube. The solar panels on our cube are approximately 100 square centimeters per side and are supposed to charge the cube in space.
Our next objective was to figure out how to open the door.
For an alternative, we used Fisher Technic parts, which are just like advanced Lego pieces, and a program called RoboPro to help us in the process of opening our door.
We had to revise our program many times to get what we were striving for. Here's our CubeSat working with Fisher Technic parts.
The only downside to this program is that it did not work wirelessly. Improving the design. Our first CubeSat printed pretty scratchy and weak, so we increased the temperature from 215 degrees Celsius to 225 degrees Celsius and decreased the travel speed from 90 to 40 millimeters per second to make the polylactic acid, or PLA, fuse together to make a stronger CubeSat.
We also improved the cube by slimming down the outer sides so that we can have more space in the interior of the CubeSats.
We then slimmed our recessed door from 8 millimeters to 6 millimeters and made the side with the wrapping pinion thicker, from 10 millimeters to 12 millimeters, so it would be properly secured.
Then we 3D printed our final design. We added supports while it was printing so it would come out cleaner.
As we finished the CubeSat topic, we quickly moved on to something new called Arduino.
When we first started, our major question was, what is Arduino?
As we researched online, we found that Arduino is an open source computer hardware and software company.
They also design and fabricate microcontroller-based kits for building digital devices.
Our next objective was to create 15 projects.
Our first project was getting used to our tools.
The tools that we used for our projects were the wires, the breadboard, and the Arduino.
Now in reality, the level meter doesn't test how hot you are, but it tests the temperature of your body.
Sadly, it did not work out because our universal serial bus, or USB cord, was weak, causing our code not to load onto our program.
So fixing this problem, we switched boards with Jake, the Arduino guru, and it finally uploaded to the board and worked.
Here's the program working on Sam.
After we got done, we moved back to Project 2, which was Space Interface.
The Space Interface is a project that made a control panel with a switch and lights that turned on with the press of a button.
We found a lot of problems doing Project 2. For example, we found out the Arduino itself was broken.
But in the end, we finally finished the 2 projects, the spaceship interface and the level meter.
Next, it was time to start the process of figuring out how to open our CubeSat.
Here, slide. And turn.
We started brainstorming and thinking ideas on how to start programming and wiring the door and wiring with the Arduino to open our door.
Using solar panels, we would use it to charge a 9-volt battery when deployed to keep safe.
There was a program called the Sweep on the Arduino website we found.
The sweep is exactly what it sounds like. The servo motor swings one direction for a period of time in a circular motion, then turns around and goes the other direction until it's told to stop.
We decided we could connect the door to our servo motor and make the swinging piece out of balsa wood. So when the servo piece swings, it pulls the CubeSat door with it.
But first we had to see if the sweep code actually worked.
Unfortunately, the sweep code didn't upload correctly.
We sought help from other groups about our wiring and coding.
Finally, we got it to upload to our Arduino and working wirelessly.
Here's our final program using Arduino to open our door.
Thank you for listening. We hope you enjoyed our presentation.